Hi all, let us try to attempt this question. State two conditions for the equilibrium of a rigid body. Condition 1. Total force equals to 0. Condition 2. Total torque equals to 0. Roman 2. Define angular momentum. Angular momentum of L equals to cross product of distance of particle from the axis of rotation and linear momentum. It shows this vector quantity. So L equals to angular momentum of a particle. R equals to distance of particle from the axis of rotation, and P is equals to linear momentum. Or angular momentum is the product of moment of inertia and angular velocity. Define all symbols. So you're able to get 3 marks, 2 marks for the conditions and 1 mark for the definition. Section B. A disk of 8 cm in radius rotates at a constant rate of 1200 revolutions per minute about its central axis. Calculate the Roman 1 angular velocity in radius per second. Roman 2 tangential speed at a 0.3 cm from its center. Roman 3 distance traveled by a point at the edge of the disk in 2 seconds. Altogether for section B is 6 marks. For Roman 1, omega equals to 2 pi f. 2 pi over 1 revolution times 1200 revolutions per 1 minute, which is equals to 60 seconds. We cancel 0, 0, 6, 20, 20 times 2. So the answer is going to be 40 pi radius per second. For Roman 2, tangential speed at a 0.3 cm from its center. Tangential speed V equals to Rajeswaran. It's not Rajeswaran, R is disk, radius of the disk, and omega is the angular velocity. So the radius from its center is 3 cm, so 0.03 meter times the angular velocity, which is, we got it from the section 1, Roman 1, 40 pi radius per second, which is equals to 1.2 pi meter per second. Roman 3 distance traveled by a point at the edge of the disk in 2 seconds. We're going to use as equals to r theta. As is linear displacement, theta is angular displacement. Or is the radius of the disk, which is 8.0 cm. Make it say question 1. A disk is rotates at constant rate, so the angular acceleration is equals to 0. So from the equation of theta equals to omega t plus half alpha t squared, the angular acceleration is 0. So the angular displacement of theta equals to omega t. Take it as 2. Equation 2. Substitute 2 into 1. So linear displacement as equals to r omega t. The radius of the disk is 8 cm, which is equals to 0.08 times the angular velocity is 40 pi in 2 seconds. So the time is 2 seconds. So the answer is 6.4 pi meter. For section C, figure 5 shows a 0.75 kilogram airplane model is attached by an arm rod of negligible mass, flies in horizontal circle 1.5 meter in radius. The airplane model acts a force of 0.8 Newton perpendicular to the rod. By assuming the airplane as a point mass, calculate the Roman 1. Talk about the axis passing through the center of the circle. Roman 2. Angular acceleration of the airplane. Linear acceleration of the airplane tangent to its flight path. Total marks for this section is 6 marks. Roman 1. Talk about the axis passing through the center of the circle. Torque equals to cross product of force and perpendicular distance from the axis of rotation. So the force here is 0.8 Newton and the perpendicular distance from the axis of rotation, so called radius of the circle, is 1.5 meter. So 0.8 Newton times 1.5 meter, which is equals to 1.2 Newton meter. Roman 2. Angular acceleration of the airplane from torque equals to I alpha, the product of moment of inertia of airplane and the angular acceleration, which is equals to m r square times alpha. Alpha equals to torque over m r square equals to torque is 1.2 Newton meter over the mass of airplane is 0.75 kilogram times the radius of the circle is 1.5 meter square. Answer is 0.71 radius per second square. Linear acceleration of the airplane tangent to its flight path from A equals to r alpha, radius is 1.5 meter, and the angular acceleration is 0.71 radius per second square from section 2. So the answer is 1.065 meter per second square. Or from Newton's law to F equals to ma, A equals to F OM, F equals to 0.8 Newton divided by 0.75 kilogram. You will get 1.067 meter per second square. If it is in 2 decimal point, the answer will be 1.07 meter per second square. 1.07 meter per second square. Thank you for watching this video. Thanks a lot, and thank you to the Lord.